This game is called Asteroids, and it's from the late 70s. It was one of the very first arcade games, and it was followed by games like Pac-Man and Super Mario. It was a very simple game, and the object of the game was simply to destroy asteroids before they ran into you, the spaceship. And in order to make this game work, we needed some simple things to happen. For instance, if you notice that when two asteroids run into one another, nothing happens. But yet we want to make sure that when the asteroids are shot by the spaceship, that they do get destroyed. And in order to make that happen, we need some simple logic things to happen. And today we're going to take a look at that. So we're going to take a look at some logic symbols that are used in that game in order to make it function as it runs. So the first one we're going to take a look at is called an AND gate. And we're going to use a program called CircuitVerse. CircuitVerse is a free program you can use online, and you can sign up for it, and we can build various logic circuits and learn about digital logic. Once we've opened it up, we're going to go into gates, and we're going to choose this one in the top left here. This is the AND gate, and I'm going to click and drag it in. This AND gate has two inputs, and in order to control the inputs, I'm going to click on input here. I'm going to drag this over here, and I'm going to drag another one in because it has two inputs. Those inputs are digital inputs. That means the input is either a 0 or a 1, or it is a low signal or a high signal, or 0 volts versus 5 volts. This AND gate has one output. So I'm going to click on outputs, and I'm going to drag this output here, and that will help us identify what's happening with an AND gate when it is functioning. We're going to join these together just by clicking on these different nodes. Basically, we're wiring the inputs to the AND gates, and we're going to wire the output to the AND gate. Make sure that your wires are connected, and we'll be able to tell for sure when we start trying to use this circuit. Basically, the way an AND gate works is we can turn on one of the inputs, and you can see this turn from a 0 to a 1. You can see this turn from dark green to light green to show that this is activated or energized as a high signal. And we can see that the output doesn't change. If I go over here and I click on this input, you can see that when that is energized, in other words, both inputs are energized, the output is also energized or on. If I turn off one of these, you can see that the output turns off. If I turn this one on, again, this one is off, so the output is low. The only time at which the output is high is when both inputs are on. And we can see that when both of the inputs are turned on. To summarize all of the possibilities for an AND gate, we use something called the truth table. And that's what we have over here on the right hand side. The inputs are A and B. That really just represents these two inputs here. These are like switches. They're on or off. This could be A, this could be B. It doesn't matter. This could be A and this could be B. And in the truth table, we can see the output. We can see that when none of the inputs are on, then the output is not on. When only one of the inputs is on, the output is still off. The only time where the output is on is when both inputs are on. So that is a two-input AND gate and how it functions in a logic circuit. We're going to take a look at another one. I'm going to click on this and click delete, and I'm going to bring in another gate. I'm going to bring in this one here, Notice its different shape. This is a OR gate. I'm going to wire this up like so, and I am going to connect the output like so, and I'm going to turn both of these off. So we can see that with an OR gate, we have both inputs are off and our output is off. But if I turn on one of the inputs, you can see right away that the output is actually turned on. If I turn this one off and I turn this on, again, we can see that the output is turned on. If I turn on both inputs, we can see that the output is on. The only time in which the output is not on is when both inputs are off. To summarize all of the possibilities for a OR gate, we can take a look at the truth table. And the truth table looks like this. As we saw, if both of the inputs were off, the output was off. If either one of the inputs were on or both of the inputs were on, then the output was also on. That is what an OR gate looks like in a logic circuit and how it functions. We're going to take a look at one more. Last one we're going to take a look at is this one here. This is called a NOT gate. Sometimes it's called an inverter. This only has one input, so I'm going to delete these here using my delete key, and I'm going to wire this up so it has one input and it has one output. And right away you can see that for this condition here, when the input is off, the inverter converts it from a low signal to a high output. If the input is high, then it converts the output to a low signal. So it only has two possibilities, and that's summarized in the truth table down here. The input is A, there is only one input, and we can see that if it is low, the output is high, and if the input's high, the output is low. So that summarizes the first three logic circuits that we're going to take a look at. That's it for this tutorial. Take care. We'll talk to you soon.